All right, let's dive into something you do literally thousands of times a day without even thinking about it: talking. We're going to peel back the curtain on the incredible science behind your own voice.
I mean, have you really stopped to think about it? How does a thought in your head turn into a sound that someone else can actually understand? It feels like magic, right? But it's actually this brilliant, super fast biological process.
And the key that unlocks this whole mystery? It's a field called phonetics. This is the science that studies the entire life of a speech sound, and that's exactly what we're going to walk through.
So picture this as a journey. We're going to follow a single sound right from the moment it's born inside a speaker as it flies through the air all the way until it lands in the listener's ear and brain.
Okay, first stop on our tour, the production line. This is the world of articulatory phonetics, which is all about how we physically build or articulate speech sounds. You can think of it as your own personal speech factory.
And here's the machinery. Just look at all the tools you're working with. You've got your lungs pumping out the power, your vocal folds creating the raw buzz, and then all these amazing fine-tuning instruments like your tongue, your teeth, and your lips that shape that sound.
But here's the thing. None of this high-tech gear works without a power source. And for pretty much all human speech, that power source is just the air you breathe out. It's the engine that drives this whole operation.
But, and this is pretty cool, it turns out there isn't just one way to get that air moving. Languages all over the world actually use three main airstream mechanisms to kick the whole process off.
One we all know and love is the pulmonic one. That just means the air is pushed out from your lungs. Go on, say the word pop. Feel that little puff of air on your hand? Yep, that's your pulmonic airstream right there. And it's the foundation for every single sound in English.
Then you've got the glottic mechanism. This is where your voice box, your larynx, actually moves up and down like a little piston to push air. It's used in a ton of languages in Africa and the Americas to make these cool sounds called ejectives. And finally, there's the velaric mechanism. This is where your tongue creates a little sealed-off pocket of air and then releases it. And you totally know these sounds. They're clicks. They're famously used in several languages of southern Africa. So, we've got our power source. But once that air is moving, we do way more than just make basic sounds. We add music to them. Phoneticians call these suprasegmental features. Think about the word really. You can ask a question, really, just by raising the pitch, or you can shout it, really, by adding stress and loudness. That's the melody of your speech.
Okay, so that's the music, but what about the actual notes? You know, what makes the B and bat different from the P and pat?
Well, that's where segmentals come in. If stress and pitch are the music, then segmentals are the individual notes, the vowels and consonants. We make these by using our mouth, tongue, and lips to sculpt that simple puff of air into a distinct sound, like an ah or a sha.
Okay, so our sound has been produced, it's officially left the speech factory, and it's out in the open. This brings us to the second part of its journey, acoustic phonetics. This is the study of the physical sound wave itself as it's traveling.
You see, once it leaves your lips, speech isn't just an idea anymore. It's a real physical thing, a ripple of vibrations moving through the air. And this is where scientists can actually measure it, looking at things like its frequency, which our brains hear as pitch, and its amplitude, which we hear as loudness.
So the sound wave has crossed the space between two people. It's time for the final leg of the journey, arriving at its destination. Welcome to auditory phonetics, the science of how we hear and understand these sounds.
Your ear is this amazing biological microphone. It catches that physical wave and translates the vibrations into electrical signals. Then your brain takes over, instantly decoding those signals and matching them up with the library of sounds and words you've known your whole life. A physical vibration becomes a meaningful thought, just like that.
So let's zoom out and put all the pieces together. The full journey, the absolute miracle of speech, from start to finish.
And there you have it, the three core stages. Production, that's articulatory phonetics. Transmission, that's acoustic phonetics. And perception, that's auditory phonetics. It's a perfect, seamless system.
So just think about that. Every single time you talk, you are coordinating your lungs, your voice box, your tongue, and your lips to create this incredibly precise physical wave that travels through the air to be decoded by someone else's brain. And the whole thing happens in a fraction of a second. It's just an unbelievable process we do without a second thought.
So next time you speak, just take a half second to appreciate the wild journey each of your sounds is taking. Because beyond the words, the pitch, the loudness, the rhythm, that music we talked about, that's telling its own story too. So what else is your voice really saying?